My name is Nico Weber. I'm an engineer on the Chrome project, and I'd like to talk about a little memory profiler prototype that we've written. And actually, I didn't write that. My coworker Daimik Gruber did, but he couldn't be here. He's working in Tokyo. So what's a profiler? Profiler is basically a tool that takes a problem and turns it into an opportunity, right? So if you have some random program that takes a lot of time and you throw that into a profiler, then you've now found a place where you can make that program much faster, which is nice. And the memory profiler is the same for memory usage. So you have a program that takes lots of memory for some reason. You're not quite sure why. You put that into a memory profiler, and then you know where all the memory goes, and hopefully you can fix it. And the state of the art in memory profilers, as far as I know, is most profilers just took malloc and then log the stacks and the allocation sizes and maybe timestamps, and then you can, using instruments or something, look at, you have many, many allocations that are exactly 16 kilobytes or whatever. What would be nice if you had type information, if you could know like 30% of your memory usage is through string ref objects or some fixed type. So type aware basically means that you can, for every address, you can look up the type of the object at that type, at that address at runtime. And also you can aggregate memory use by type, like 40% are string refs, 10%, I don't know, file handles or something. And there is like one existing system that does this, that's called memtrack. And that uses, basically defines new to some magic class that does some trick that basically writes some site table with all kinds of type info stuff. And that kind of works, but it uses a define, so you need to inject that into all your translation units. And also if you write operator new, then the new gets replaced by that magic code and that no longer compiles. So what we came up with is basically a compiler-based instrumentation. Every time the compiler has a call to global operator new, it replaces this with a call to under op new intercept, which receives the result of operator new, and then it also passes in the allocation size and crucially the type info, the std type info. And then it's up to user code to implement op new intercept. So in our case, we have some information in Chrome that does something interesting. A somewhat less interesting example is just to log all allocations. So this just does an printf and says allocated so and so many bytes for this type at this address. And then you link this and use this new flag to Clang, and then you basically see all allocations. And we got this, so we have a prototype that's actually working, does like multi-threaded allocation tracking and so on. And it looks like 30 to 40% of Chrome's memory usage and the UI process are due to strings, which is interesting, I guess. And we hope to use the same technique to provide data on Clang and LLVM memory usage. And eventually, we'd like to hopefully upstream something into Clang that enables this functionality without having to use a forked Clang on some bot. So Dai will probably reach out to the Clang mailing list eventually, the next few weeks, and talk with if this is a good approach, if other approaches are better. And I think that's already it. So, thanks.